All right, this part 2 is all about application problems. So the first one was pretty easy, and most of you had the system correct. Some of you asked if you had to do the let statements since they were just numbers, and I said no. But the sum of two integers is 11, and the difference is 41. So most of you, again, solved this by combination. These were already opposite, so all you had to do was combine them. So 11 plus 41 is 52. The y's canceled, and then this next part is where many of you made your mistake. X plus x is 2x. So x is 26. And then we can put that in for x. So 26 plus y is 11, and then subtract to get negative 15. Now I'm not going to take the time to check every single one of these because I want to keep the video shorter, but I am telling you, you need to be plugging your numbers in. Some of you did that mistake that x plus x is x, and you could have caught that had you plugged your numbers back in. All right, I wrote this out to save us time, but let me go through it with you. So here's my let statement that, again, many of you are not doing. Let x be the cost of the hamburger, let y be the cost of the coffee. Where I got that from was this right here. What is the cost of the hamburger in each cup of coffee? Please, if nothing else, you need to at least have the let statement. And then what we know is Lair ordered 4 hamburgers and 1 cup of coffee for $24.75. Some of you might want to consider putting, after you do your let statement, putting the variables up front. So hamburgers was the x, cup of coffee was the y. So again, the cost of them, not the number because we know the number. So now I see 4x plus 1y equals $27.75. And LaRue ordered 1x and 4 y's for $16.50. So this is my system. I chose to solve it by combination. So if you chose combination and you got it wrong, you hopefully will be able to see your mistake here. If not, you might have to go just double check your arithmetic. So I did negative 4 times 4x, negative 4 times y, and negative 4 times 24.75. And I combined down, so x minus 16, oops, I'm missing an x, is negative 15x. My y is canceled, and this is negative 82.50. So I divided by negative 15 to get $5.50. And then I plugged that into the first equation and solved to get the 275. Again, plug these numbers in to make sure they work. I was actually very impressed with how many of you got the mixture one right. You set up your table beautifully. So dark chocolate, peanut butter, new. We didn't know the pounds of dark chocolate or peanut butter, but the 10 was the new. We knew the price of the dark chocolate was 3.5 per pound. Peanut butter was 4.3 per pound, and the new we wanted to charge I think I said 4.30 here, 4 per pound. And so to get the total cost or the total value, you would take the pounds times the amount, pounds times the dollar amount, pounds times the dollar amount. So again, this is our first equation, and this is our second equation. I chose to solve this one by substitution. So I subtracted x from both sides. Here's my new equation. So I took this expression and slammed it in for this y. So I replaced y with 10 minus x because I knew that they equaled each other. I did the distributive property. I combined like terms, subtracted 43, divided negative 3 by negative 0.8 to get 3.75 pounds. Many of you are forgetting your labels. You need to tell me what these numbers mean. And then I plugged it back in over here to get the 6.25 pounds. And it looks like inches, but it really is pounds. Pounds. All right, and for the level 4, I was pretty impressed with how many of you started in the right way. I gave you the hint to use distance equals rate times time. So let x be the rate of the fish and y be the rate of the current. So that was the first part. And then I said use distance equals rate times time. So the distance was given to us, 100 in both cases, and the time was given to us. It was this rate. And you needed to think about what it would be like to be in a current. So I don't know if you've been in a river before, but the current kind of pushes you along, or you could be going against the current. So if you were going swimming downstream, the current is pushing you forward. So that means you have the rate of the fish plus the rate of the current. So how fast the fish is actually traveling is how fast he's swimming plus the rate of the current. Where if you're going against the stream, against the current, so you're trying to swim upstream, you have the rate of the fish, but the current is pushing against it. So you have to subtract the rate of the current to get how fast the fish is actually traveling. So the rate going with the current is the rate of the fish plus the current. The rate going against the current is the fish minus the current rate. So that's the rate. So then to solve it, I just divided by 8 and I divided by 20. So I had these two, and the reason I did that instead of the distributive property is because now I have opposites. So then I combined them and I just plugged this. Once I got that, I just plugged that value of x in to find y. So it was the whole idea of understanding that the rate, if you're going with the current, you have to add the current, add the two rates together. If you're going against the current, you have to subtract.